Well, well, well. It's another exciting day for space weather. Things showed up a little bit earlier than expected. Everybody was wrong with the forecast. We've got scintillation of the ionosphere and a conflagration of sunspots around the eastern solar limb. We'll tell you all about it and lots more on today's Daily Space Weather Show, brought to you by the Smash News Network, least busted name in news. These are 24-hour videos of the closest star, El Sol Helios, the local yellow dwarf, otherwise known as the Sun. It depicts the ultraviolet emissions from extremely hot ionized iron gas in the Sun's lower atmosphere, known as the corona. So we've got two new named sunspot groups over there on the eastern limb, and a small uptick in solar activity since yesterday. There's the new sunspot group rising in the southeast. And let's don't forget the new sunspot group that's risen in the northeast. So at least two more sunspots likely to get names today. And a brief moment to thank our new YouTube subscribers. So we've seen massive increases in our channel viewership over the past few months, so thanks to everybody for that. Don't forget to press the subscribe button if you're new to the channel. It's only the world's most comprehensive daily space weather content and most detailed solar imagery you'll find in the known universe. We didn't just want the oohs and ahs of the incredible solar imagery, we also wanted all kinds of other science stuff associated with the channel. So it took us a while to figure out what to cover, and there you go, the Daily Space Weather Show. We bring your space weather and Earth weather together all the way from the photosphere of the sun down to the lower 48. So once again, thanks to our new subscribers. If you're new to the channel, press subscribe, press like. If you're not new to the channel, help us out with the algorithms with those likes, comments, press the share button, etc. We did get some weak aurora in Pennsylvania last night. Here's a little clip of the video. It's some time-lapse footage. It's not super exciting, but there was certainly a lot of super exciting aurora visible last night as far south as Oklahoma. We'll show some footage of that a little bit later in the video here. By the way, if you want to support the channel, and please do, we would prefer these videos to continue to exist, remain publicly visible and free for all to view. Visit the links below the video. There's a Hemp Lucid sale going on right now for Sleep Stacks, Stress Stacks, Full Stack Package, and the Immune Stacks. So save some dough on those. They're only the best. And there's the ones that are most popular more than the rest. The CBD tinctures, CBD caplets, and so forth. Links below the video and on the homepage to the Hemp Lucid store. The homepage is smashomash.com, and welcome to the Neo Renaissance, folks. Congratulations on realizing the channel exists. So visit the homepage, hit us up on social media. If you've got stuff you'd like us to share on the videos, we'll consider it. Just drop us a line. We're pretty easy to reach in all kinds of different locations. Smashomash.com. Also check out the Amazon shop. Today's featured list is the Spacewear list. If you're looking for some chrome pants, perhaps some chrome shoes with light up LED soles, yeah, you can find those. Maybe a chrome shirt. Or what about some Hawaiian shirts? I'm a collector. What about some eclipse glasses? We've got the low and the high quality products available there. So check out the Amazon shop. It's amazon.com/shop/smashomash. Thanks to everybody who's picked up products from there. Today's featured product is from our merch shop. Please do not pole vault the caldera. We don't want our viewers to become part of the lithosphere, as we need the views on YouTube. Just kidding, folks. In all seriousness, if you're going on a volcanic vacation, leave that vault pole at home. Don't pole vault the caldera. It could be unhealthful. This public service message brought to you at massive personal risk and expense by Smash staff and I. Give her a raise by picking up some products. Go out and tell your friends and foes about the channel. Perhaps wear the shirt or something like that, and get blank stares at parties while you start to tell people about what space weather is, what's going on the closest star, and things like that. In any case, our finest days lie ahead, so if you're going through hell, keep going and don't pole vault the caldera. It could be unhealthful. So next we'll show some views of the closest star here. We do see some umbral growth and some umbral evolution happening in this group. Also this group down here. Those umbrae moving at different speeds. The differential rotation of the closest star there highlighted. The sun rotates a little bit faster at the equator than it does around the polar regions. Anyway, once again, we've got two new sunspot groups that'll likely get names today. One in the southeast and one in the northeast. Here's your colorized magnetogram. Like the intensitygram we just showed, this depicts yesterday plus today. It's the SDO Browse Data feature. It's totally sweet in that it allows you to rocket back and forth if you want to. Yeah, you see? Very nice. And before we get back to space, let's see what's going on planet Earth for a brief moment in terms of volcanic activity. Subanosei-jima is exploding, producing a 10,000-foot ash plume. That's a major uptick there at Subanosei-jima. So flight level 100 there in the Ryukyu Islands near Japan. Luitolo also erupting, producing a 7,000-foot ash plume. And Ruby, part of the Mariana Islands. What's up with that? The eruption onset was not observed in geophysical data. However, a retrospective investigation of seismoacoustic data of the Saipan monitoring network captured eruption signals on September 15th. So the alert level has been raised there at Ruby, the Ruby volcano in the U.S. Mariana Islands, not to be confused with marinara sauce. Popocatépetl, possible emissions there in central Mexico. Interesting, so maybe a downtick at Popocatépetl. Fuego in Guatemala continues to explode. It's producing about a 15,000-foot plume of volcanic ash now over Guatemala. Sangay in Ecuador. Volcanic ash not seen in satellite. Don't assume it's not erupting and try to pole vault the caldera. Revenador exploding, flight level 140. That is located in Ecuador. As it explodes, it's a flight level 140, 14,000-foot ash plume. Continuous emissions from Sabancaya in Peru and Villarrica continuing to erupt at stable levels, characterized by a delicate equilibrium between incoming and consumption of magma. All right, let's see what's going on with earthquakes. We do have high seismic activity here at the moment. And let's see what has been shaken on planet Earth. There are the past 90 days, and the largest quake was a 6.3 located northeast of Taiwan. It was at depth, nearly 200 kilometers estimated depth, so it would not have produced a tsunami. It occurred at 1321 Universal Time, and we've had a conflagration of quakes around the California coast as well. So no quakes over a 5 magnitude. We will cite all the quakes of a 5 or greater magnitude for the past 24 hours. That 6.3 was the first one. Again, it was at 1321 Universal Time yesterday afternoon. Next on the 5 and greater magnitude list was a 5.5 here, much farther north there on Japan. That was at 1933 Universal Time yesterday evening on September 18th. So a 5.5 there. It was at some depth, 64.4 kilometers. Moving right along. So only a couple 5 or greater magnitude quakes. Keep in mind, folks, any earthquake can be a foreshock. Next on the list and last on the list is a 5.8 at Japan there. That one south of the main islands of Japan. That 5.8 at 6:22 Universal Time this morning. Let's just briefly take a look at the California coast here. One of those quakes was about a 4.5 magnitude there south of Modesto. And let's get back to space. Space, a frontier. These are the voyages of the SDO. its continuing mission to provide awesome imagery of the closest star in 304 angstroms, ionized helium. That's another 24-hour video there. And the most active region has been up in the northwest. We've got a high likelihood of solar flares both around the eastern limb and in the northwest. At the moment, we're seeing some plasma instability happening in the northwest. That would be this area right up here. We've also put together 193 angstroms here. We've added that to the 304 angstroms to show some additional contrast, to show the extended corona, and to show solar filaments and coronal holes. Most of the solar features you can expect to see are visible in these wavelengths. Let's take a brief look at a little bit of a closer view here. Here's the northern hemisphere. Several large plasma filaments indeed hanging out up there. Here's the equatorial zoom. Again, a fairly high likelihood of large solar flares both in the eastern limb and in the northwestern limb. Well-defined coronal hole here rotating right past the Earth strike zone. We can expect a small intensification in solar wind in about three days or so from that coronal hole. And we've placed the Earth scale here near the Eugene-Bagashov filament, which has repositioned itself farther to the east to remain in view for a longer period of time. How you like them apples? Pretty sweet, right? And let's talk about some stats. The 10.7 centimeter radial flux now up to 155 solar flux units. So an uptick in solar activity in the past few days, and you can expect an uptick to continue for the next year plus, as we are nowhere near solar maximum yet. And there's the one-year graph to contextualize what I've just stated. The black line is the 10.7 centimeter radial flux. The red line is the sunspot number. Those are the two most important features in the analysis of where we are during a solar cycle. So NOAA, NASA, Tamitha Skov, and I were all wrong about our timing of the coronal mass ejection impact. So that's one of the reasons that our channel is so valuable, because we forecast these things as earthly directed very early in the process. You'll notice that the CME wasn't even out of the corona yet, and we already forecasted that it was going to be earthly directed. But this is what happens when you don't have stereo A to help calculate the speed of these CMEs, coronal mass ejections. When you don't have stereo A, it's very hard to calculate that speed. So we were off by between 33 and 50%. So that coronal mass ejection was moving much faster than expected, and we're expecting now the geomagnetic storm conditions to subside here over the day. Why? Because I forecasted that it would last no longer than about 18 hours, and we're pushing about 18 hours now. So expect it to subside. It was moving a lot faster than any of us expected. So that's the NOAA forecast there, and a lot of that is going to be canceled there. The tail end of that CME is already passing by, we think. But that's the situation. We still do have elevated conditions and a scintillated ionosphere, which we'll cover in a bit. So here are the past 4 hours of Earth's magnetic moment from space. And we do have a lot of high-density plasma here. What you're seeing there, those sudden variations, those are a switching of the instruments. So keep in mind, this is a model, folks, and that makes it super obvious that it's a model because, well, the solar wind probably didn't change that much. There are two different spacecraft that are typically used, the ACE and the Discover, and what you're seeing there is a switch from one active spacecraft to the other one, so that affects how the model looks. Those huge variations are probably anomalous. Here are the past 4 hours of Earth's magnetic moment from the ground, and you're going to see a similar huge swing here in the Space Weather Modeling Framework's guesstimation of the ground magnetic perturbations map. And we'll show you why that is here in a moment when we get to the real-time solar wind data. So lots of aurora seen around the Earth, lots of fantastic imagery shared on our Twitter account. Again, we do think the thing is subsiding now. We're sort of seeing the trailing edge of that huge plasma cloud. That's Earth's geoelectric field, by the way. Let us know in the comments if you've used this to see the aurora at your location. So we did see some shares here from AccuWeather. Here is some imagery from Drayton, North Dakota. Some great green curtain-like aurora there, along with some purple aurora. And we did see it get as high as a KP7. So pretty much in line with the forecast there as far as the intensity and the orientation of the CME. Just, it's very, very hard to tell the speed of a coronal mass ejection when it is traveling directly toward the coronagraph. So there's no data because stereo A is so in line with the Earth. It's very hard for us to calculate what the speed is of those coronal mass ejections. Again, it did get as high as KP 6.67. And here are the parameters. So we put up a 3-day. We usually show a 1-day chart of the solar wind. Today we put up a 3-day just to make this real obvious. Here's the CME Impact. Just after 12 noon Universal Time yesterday. So even NOAA was off by about 24 hours there. So CMEs usually take about 3 days to arrive. This one took 2 days instead, so it was moving about 33% faster than even NOAA forecasted. The rest of us were off by about 50%. So huge margin of error there showing up. And that's just the way the cookie crumbles. Here's the 1-day chart to show you all the details of that. And what happened was when it first showed up, there was a very strong field. So we saw a BT of 19 nanotesla with a BZ of negative 15, as you can see there. Solar wind density popped up to 16.3 protons per cubic centimeter. And then the speed remained elevated here. So about 600 kilometers a second there. About a third faster than it usually shows up. So that's in line with what we saw happening. Everything making sense there. The CME was moving much faster than anticipated. At the moment, you can see it is subsiding. We are seeing a return to the plasma temperature that happened before the CME arrived. So that's an indication that there is a subsiding of that coronal mass ejection. Current conditions are as measured by the ACE, which is the green bar at the bottom there. The ACE currently showing up still an elevated solar wind speed and a very low solar wind density there. Barely less than 1 proton per cubic centimeter for the solar wind density. Solar wind speed here, 581 kilometers per second. And let's take a look at some more stats here. The GOES magnetometers here showing some very sawtooth readings from their geosynchronous near equatorial orbits, as we forecasted yesterday. So there you go. The CME Impact there. And you can expect those to smooth out in the coming days. Next, our top view ecliptic plane field plot. And it looks like Earth is still in a South Pole current sheet as forecasted. You can expect that to persist for a day or two. Keep in mind, if we do see sudden evolution of those sunspots on the eastern limb, then that could suddenly change with basically no warning besides our channel. Here's our line of sight field plot depicting the solar B field in blue, north solar polar fields in green, south polar fields in red, and the photosphere magnetism there shown in grayscale. It's a long way to solar maximum. It's a long way to go. Here's our line of sight coronal hole plot. And yeah, we've got north and south pole oriented coronal holes here on the Earth-facing portion of the solar disk. That one right moving past the Earth strike zone, that is a south pole coronal hole. Let's check that out in the SDO 211 angstroms wavelength. So there you go. There's a 24-hour video for you. That's one of the many species of ionized iron covered by SDO. We can expect a short-term intensification of solar wind parameters in about 3 days from that Earth-facing coronal hole. Anyway, that brings us to sunspots. So let's take a look at the sunspot scenario. Again, we've got 2 new sunspots likely to get names on the eastern limb. So this one right here, That'll get a name today most definitely. This one here is kind of weak, but we did see Umbra. We'll show you some high-res imagery of that before we get to our meteorology segment here. 2 new sunspots. It's a conflagration of sunspots on that eastern limb. Next, the past 24 hours featuring the HMI instruments intensity gram and the AIA instruments 94 angstroms wavelength. Again, we've got a possible new sunspot forming there in the northern hemisphere as well. So it is a solar uptick, and this is great at highlighting the active regions. Again, we could see large solar flares both in the northwest and around the eastern limb at the moment with the magnetic field orientations that we see. Here we've subtracted 94 angstroms just to include the SDO continuum, another 24-hour video. And indeed, another sunspot has formed up here. So at least 3 new sunspots have formed since yesterday's daily space weather video. If you're very worried that the sun is shutting down, maybe this will allay your fears. Here's the SDO magnetogram for the past 24 hours. And let's move to energetic particles and solar flares. Some more sweet imagery for you here. Now, we did see a minor proton event. So there was a bit of relativistic particle that showed up there. That was yesterday around 5:40 was peak flux there. But it was a minor event, and it has since subsided. So the goes proton flux here back to baseline levels. And the largest flare of the past 24 hours occurred just earlier this morning at around 9:40 Universal Time. Peak flux was M1.6 or so. And here come some fantastic images from, once again, the Solar Dynamics Observatory. Here we've got, that's 131 angstroms plus 304, so ionized iron and helium there. It's great at showing filaments, active regions, and solar flares. And that most recent flare came from above the Earth scale there, that sunspot on the east. That was the M1.6 flare right at the end of the video. Here we've swapped out the 304 angstrom for 94 angstroms. And since we encourage our viewers to look up, let's do that. Here is our skyandtelescope.org star chart. If you want to make your own, just head to skyandtelescope.org and put in your location. There was a great view of Venus this morning when we were looking to film some more possible aurora. We saw a KP7 alert, so I went out promptly to my local viewing spot of the northern horizon. Also, Venus is currently up there on the ecliptic there over Lehigh Valley, Pennsylvania, where we're located. And if you're new to the channel, drop us a line and let us know where you're located. And of course, if you did see aurora, hopefully you took videos and photo of it. Did you know that the aurora is mostly in ultraviolet light, which means most of the aurora is not visible to the naked eye? So if you think you're seeing aurora, take some video and or photo of it, because your camera will be able to pick up spectra that is not visible to the naked eye. So those are some facts for you. Here come some facts about the solar system. We're going to show the 1-week forecast. I guess that's part of space weather. This is where things are today. There's where things will be on the 26th of September in 1 week. Next, today's astronomy photo of the day. And this is a humdinger. This is a Herbig-Haro object. Herbig-Haro objects are believed to be young protostars. This one might even have a planetary system, not sure on that. But that star is producing some insane jets. There's a great image there. The star is where that dark area is located. as it is covered by dense dust and gas. But a spectacular view there of that Herbig-Haro star's stellar jets by the James Webb Space Telescope. So all stars have polar jets. Some of them are more rowdy than other ones. It depends on many factors. The intrinsic properties of the star as well as its interaction with its interstellar environment. So very dusty there where that star is located. Dusty enough that it obscures the star even in infrared, as you can't really see the star, but we know where it is because of those jets. Herbig-Haro objects. They are one of the more intrinsically gorgeous features that you'll find the James Webb Space Telescope taking some spectacular infrared imagery of. The apod.nasa.gov astronomy photo of the day, there it is. It is HH211. Moving right along to cults. So, I mean, we talk about cults regularly on Twitter. As the world, I think it has more cults right now than have ever existed before. It's pretty bizarre. You know, cults, a little on the creepy side. And, you know, the main features of cults that I always like to cite is they have to have a living leader, usually self-appointed. They have to be harmful, and they have to believe nonsense. Those are the three factors that I consider a cult. And again, there are plenty of cults right now. So let's talk about one of the cults that appears regularly on our comments. Here's one. Eyes Wide Shut 7732 says, look at reality. Space is a joke, and Earth is a level plane. So I said, Eratosthenes accurately calculated Earth's axial tilt about 2,200 years ago. So, I mean, look, flat Earth types. If you could explain through one simple, elegant theory why the stars in the southern hemisphere orbit the celestial pole clockwise and the stars in the northern hemisphere orbit the celestial pole counterclockwise, and lunar eclipse, and day-night transitions, and the seasons, all with one theory, you'd be using Occam's razor, Occam's razor, to simply explain why all of these things occur, not with insane, crazy nonsense. So, I mean, for thousands of years, most people have believed the Earth to be an oblate spheroid. Anyway, if you still think the Earth is flat, you are more out of gas than a Tesla. So one of the great ways to I guess argue with people. Now, of course, if it devolves into insults and stuff like that, then the argument is over. So just tell people that they're a moron. Eratosthenes very accurately calculated both the Earth's axial tilt as well as the circumference of the planet in like the year 200 BC, so over 2,000 years ago. Why? Because he noticed that the sunlight made it all the way to the bottom of a well at Syene, Egypt, and that on the same day of the year, a pole cast a shadow at Alexandria, where the library is located, and that allowed him to do basic geometric measurements and calculations and accurately determine both the Earth's axial tilt and the circumference of the planet. So another great cult that we get comments from constantly on the channel is the Nibiru cult. Yeah, Nibiru cult. So if you're on Facebook, you're probably seeing people constantly putting up nonsense where they take images of lens flare or images of other various astronomic objects and claim that it's a spooky, spooky doomsday planet. The best argument against Nibiru, since it doesn't exist, is occultation. So people with backyard telescopes are able to very easily see things, right? So if there's a planet floating around in our solar system, even if it's completely pitch black and it doesn't emit any light, people would still see it because of occultation. Occultation is when one object moves in front of another object. This is how people with cheap backyard telescopes regularly discover asteroids. So there you can see the moon occulting Saturn. Planets are big, and they get in the way of things. Again, this is how people discover asteroids regularly, previously unknown asteroids, because they're looking at something and it gets covered up by something else. It's called occultation. This is how we know there is no spooky doomsday planet floating around in the solar system. So tell your friends and foes, maybe send them this video along with a timestamp so they don't have to waste their time talking about facts about space when they're very busy talking about fiction about space. Next, CMEs. Here are yesterday's CMEs from George Mason University. And indeed, there was one there that looks like it could have a possible earthly directed component, right? That one right there, coming out of the northwestern limb. You think that one might be earthly directed? Well, we're going to analyze it here, right before your very eyes. That's 94 frames from yesterday. Here are an additional 13 frames from today. And it looks like there is another CME there happening. We may have to make another video later in the day today if that is earthly directed. Anyway, here are Soho-Lasco C2 and C3. Let's pause at today's CME here. So that is definitely from the southeast. Let's take a look at that in a little greater detail here. Zooming in a little bit closer. So there's that coronal mass ejection from yesterday. Looks like two events there happening around the same time. One out of the east, one out of the northwest. We don't think that one is earthly directed, but let's take a closer look here at this more recent one from this morning. All right, that's all we get at the moment. Let's also take a look at stereo A, which unfortunately is not going to be very helpful. There's yesterday's CME. The one from this morning there not showing up yet on the imagery. So let's take a look at our custom coronagraphs. Here's a 24-hour video. And this one should show us if those CMEs are earthly directed, at least the one from yesterday. So we don't see any limb darkening or plasma motions happening up here in the northwest. So we suspect that that is going to be on the far side of the sun. Let's get it a little bit closer here. So we don't really see any activity happening just preceding that CME there right at the beginning of the video. That is on the far side. So not likely on the Earth side there. The more recent one, which is out of the southeast, right there at the end. I think that one is from behind the limb also, so also not likely to be earthly directed. And here's just 193 angstroms by itself. So when we do see more coronagraph imagery there, we may have to make another video about that if it is earthly directed. But so far, based on preliminary data, it does not look like it's Earth directed. So moving right along here to Filaments. And we'll take a look at the El Teide, Spain hydrogen alpha telescope there. And we've got some named filaments here. So we still have the Eugene Bagashov filament down here. We have the Scott McIntosh filament here becoming a prominence. Part of the Tamitha Skov filament, the one that struck Earth yesterday and into today, is still intact there above that active sunspot. That could produce another CME. And then over here we've got the Reed-Timmer filament, named after storm chaser Reed-Timmer. So more filaments here in the eastern limb. There's one down here in the south that doesn't have a name yet. If you want to name filaments, do it over on Twitter. Follow the hashtag #NameThatFilament. Here's the grayscale. So that's the scenario. And if you want to see all of our Aurora shares, again, follow us over on Twitter. So there's all kinds of interaction going on over there on Twitter. We have probably over a dozen shares of fantastic auroral imagery and videos. You have to follow us over there to see it. We're not going to show it on the YouTube channel because this is our content and that's their content. They need credit for it. So again, if you want to name filaments after living people, it's fascinating to do so. Follow the hashtag #NameThatFilament thanks to our new followers over there on Twitter. One of these centuries, we might even reach 500. Before we get to bonus features, let's take a look at the past couple of hours here in a CME happening while we produce the video. So it looks like another eruption of the Tamethyscove filament, which has partially ejected, partially stayed intact, and now it looks like another bit of it is blasting off. Good times there, good times in the northwestern limb of the closest star. So you can also see some plasma instability over there on the eastern limb. No surprise there. And let's do bonus features. Satellite charging hazards. We do have some significant surface charging hazards there as low-energy electrons are building up on the surfaces of satellites there around places like Central America, the Caribbean, the Gulf of Mexico, and the Eastern Pacific. So you could see some minor communications failures there as a result of those surface charging hazards. Don't say we didn't warn you. Them's the facts. Goes electron flux here coming up off the floor as we see that coronal mass ejection impact subsiding. Probably no surprise to our regular viewers there either. There's the 1-year graph of the electron flux to put it in context. It is the greater than 2 mega electron volt electron fluence for the past year as measured by the GOES 16 and the GOES 18. That's from solon.info/solar, by the way. There's the forecast model, and NOAA is expecting an increase in the electron flux. I would tend to agree. Next, we'll show the ionosphere, which is rife with low-frequency anomalies, as you may come to expect with the massive scintillation caused by that coronal mass ejection impact. It wasn't as strong as it could have been, but you're going to see a lot of low-frequency anomalies here. So here's the raw vibrational frequency in megahertz. As the ionosphere has puffed up a lot. This is one slice of the bridge between Earth and space. The F layer is at about 300 kilometers average altitude. Again, you'll see a lot of low-frequency anomalies here. And here's the anomalygram. Look at all that red. We were expecting that about a day later. So again, that CME arrived at about 33 to 50% faster speed than anybody expected, including NOAA. But at least we forecasted that it was earthly directed while it was still on its way out of the corona, folks. So, but there are the effects in the ionosphere there. The ionosphere getting scintillated by incoming plasma from space. You can expect that to last for about 36 hours. We'll let it play through one more time and then show the latest image. There's the scenario at 11:45 Universal Time for the ionogram and 11:45 Universal Time anomalygram. Low-frequency anomalies galore. We'll also show the total electron content forecast. We are seeing some anomalies in the total electron content as well. It's free electrons to about 12,500 miles of altitude. The inner portion of the outer Van Allen belt is where your GPS satellite is located. And here is your total electron content forecast. So no major anomalies here, some nighttime high electron counts. But most of those electrons are fairly organized there, where you'd expect them around the equator at noontime. As solar radiation ionizes the Ionosphere. Next, the anomalygram, that's anomaly from 10-day average. We are seeing significant high electron count anomalies over places like Central America, Central Mexico, Baja California, the East Pacific, and the west coast of the U.S. If you're new to the channel, this is literally a count of the electrons, and this is displaying the anomaly from the 10-day average for the total electron content, the free electrons from ground level to about 12,500 miles of altitude. We'll close out the space weather section of the video with the latest intensitygram and latest colorized magnetogram. Take a look at these new sunspots. So the eastern limb, a bunch of new sunspots there. That one right there is the most active at the moment. We are seeing plasma instability there. The likelihood of solar flares is there. Also over here, that is also a beta gamma delta class sunspot group. So it's capable of producing large flares. Let's take a brief look at this new sunspot that just rose in the northeast. And there's the rest of the eastern limb for you. I think this is a new sunspot as well, isn't it? So we may have 4 new name groups today, at least 3 new name groups today. It's another significant solar uptick, and expect lots more significant solar upticks coming, again, because we're like over a year from solar maximum. So let's get to our meteorology segment here, a regular feature of the Smash News Network Least Busted Name and News. We're bringing the weather all the way from the sun down to planet Earth. So first thing we're looking at here is Saharan dust. This low in the Atlantic is entraining a little bit of Saharan dust, but it's not super thick. The really thick dust is just off the coast of Africa here at the, what is that? Réunion. And yeah, so a little bit of dust being entrained by that low. Shouldn't have too significant of an effect on it. Let's take a look at Earth's air masses here. So first, the surface winds of the east. Shout out to our viewers from this side of the planet. Here are the jet streams of the east. Here are the jet streams of the central world. The jet streams, they are in control of your weather, moving your weather from west to east for the most part. Here are the surface winds of the central world. What's going on up there? An oddly shaped low there, south of Iceland. Last but not least, the surface winds of the west. And there are the jet streams. Now let's take a look at the low here. The low is not that low. It's only 990. Is it hectopascals? 990 hectopascals there. So not a super powerful tropical low there. And let's just do a 3-day forecast to see where the Euro model and GFS model place it. Dag. It's going to rapidly move there. So there's the GFS model, and there's the Euro model, both showing a low here forming off the coast of Florida. Let's actually zoom out one level there. So that low is going to make a rapid turn to the north and east, according to both the Euro and GFS models. Not going to strike the U.S. The jet stream will prevent that, and it looks like it's going to stay pretty steady there, dropping down a little bit to 985 hectopascals. Next, clouds and fog over the Americas. Shout out to our viewers from all around the planet. Who knew we would make so many friends and foes by citing facts about space and Earth weather? Gee, what a contentious thing, folks. Facts. Facts and science. Very controversial in the year 2023. Next, our weather.gov map. Some flooding forecasted for Maine. There's the key. That's about all we're going to show you. Weather.gov is where you can get your weather warnings. And here comes some forecasts. This is the GFS 72-hour pressure and precipitation forecast. Some snow coming to Idaho and Montana. Perhaps, Washington as well, it looks like. Next, total accumulated precipitation forecast in inches, based on the same GFS 72-hour model. And some heavy rains there coming to especially Oklahoma, also Florida, and of course, Maine. Last but not least, the jet stream forecast depicted by the 250 millibar winds. The 72-hour GFS model for the jet stream, which is in control of your weather. Not chemtrails, not contrails, not HARP, not geoengineering, and not cloud seeding. The jet stream is responsible for pushing systems from west to east, not humans. If those facts are too controversial to you, sorry. Next, our lightning mapper. We have had some thunderstorms there across Iowa, Texas, and Oklahoma, especially also parts of Florida, seeing some lightning over the past 10 hours. Do we have any current terrestrial strikes? It looks like we do still have some thunderstorm activity there in Iowa. As the Terminator moves across the western Mississippi Valley. The Terminator. You know, the day-night line, the Terminator. I suspect Des Moines is in the crosshairs there. There is thunder rolling in places like Ogden. Also some activity here in Missouri, east of Wichita, and around Edmond, around Oklahoma City, actually. So that's what's up. And by the way, if you enjoy the channel and you'd like to see it continue to exist, remain publicly visible and free for all to view, consider becoming a member of the Smash Team. We send out email alerts so you don't miss videos like this one. We produce additional content for our gold and silver Smash Team members. There's even a bronze level. That costs you $0 per month. Silver is $2.99. Gold is $9.99 a month. In 2019, a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped the maximum security social media stockade of censorship and pathetic nonsense, where we survive as producers of fortune. We escaped to the internet underground. If you have a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash Team. No, you definitely can, as you can certainly visit the website linked conveniently at smashamash.com and below this very video. We'll close out with Doppler radar, clouds and fog, and water vapor. We showed the full 50-state view. Here's the lower 48 view. Chicago is in the crosshairs. There is the clouds and fog shortwave radiation map from the perspective of a satellite. And by the way, you can notice Earth's curvature on that imagery. Here's the water vapor map. And a lot of dry air over the eastern portion of the U.S. here at the moment. Some moisture just about to cross the Mississippi Valley. Anyway, this is where we'll close things out with a recap. Ground-based Doppler radar systems, which show vertical motion in the air column. Space-based system, which shows infrared radiation at 3.9 micrometers, and another space-based system which shows infrared radiation at 6.19 micrometers, showing all of the water vapor, which should clear things up, especially if you understand basic physics. So anyway, you too can forecast your weather, whether it's coming from space or from the ground. We empower our viewers to do that and to understand facts. Pardon the controversy of all the facts. We'll be back again to do the daily space weather tomorrow. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off, and may that solar wind be at your back. I'm going back to the bunker again. Lots and lots of nonsense have encouraged me to go in.